All right, so these are the three examples we're going to do using the first derivative in solving this algebraically. So the question's asking you to state intervals of increase and any max and mins. Today you have the graph next to you, so you know you have a maximum, you know you have a minimum, you know you have 1 and 2 intervals of increase and 1 interval of decrease. But let's show how we support that just using the first derivative algebraically, because you will not be given the graph in the future. So here, when you hear the words max, min, and you know that's all means relative extrema. So any of those words come into play. Or you also hear interval of increase or decrease. I want that to be a bell going off in your head. Increase, decrease, relative max, relative extrema, max or min. That all means you need to find the first derivative and you need to perform the first derivative test. So let's get started. Here comes the first derivative. This is just going to be done by power rule. So 3x squared minus 6x, and the derivative of 4 is 0. So our next step is to find the critical values. How do I find that critical value? I see, does the first derivative equal 0 or the first derivative undefined? Well, here, the only time anything is undefined is when I have a restricted domain. And I don't have a rational function, so I'm not going to have a situation where my first derivative is undefined. But I can see about setting that first derivative equal to 0 and looking for critical values. So when I do that, how do you solve anything for a variable that's larger degree than 1? You factor. There's a GCF of 3x. You pull that out. I'm left with x minus 2 equals 0. So now you go ahead and you set each factor equal to 0, trying to solve for those critical values. And I find 2. I get x equals 0 and x equals 2. These are what I call my critical values, and that's just going to be the initials that we'll be using from now on for critical values. And if hopefully you're looking at your notes, after you find your critical values, you put those critical values on the first derivative number line. So you create a first derivative number line, and there's no closed interval, so I'm just going to use arrows. If they said find the first derivative from -5 to 6, well then -5 and 6 would be my end values, and I would look for any critical values within that interval. However, here my critical values are just 0 and 2. So now I went ahead, critical values, put it on my number line, and now I have to perform my sign test on the first derivative. Here's the first derivative, right here. You want to perform the sign test on the factored form. I believe that's the easiest. So I'm going to take 3x, x minus 2, which is my first derivative, factored, and I'm going to plug a number in from the left, a number in this section, and a number to the right. You don't plug in the critical values. That would just give you 0. So I'm going to plug -1 in. And I don't care about the value, I just care about the sign. So here, 3 times -1 is going to be a negative value. It's going to be -3. And then in here, if I did -1 minus 2 is also going to be a negative. A negative times a negative will result in a positive value. So when I take any number here and plug it into the first derivative, my output will be positive. Okay, now I need to test a value from 0 to 2. Well, 1's an easy number. I'm going to take 1 and plug it in. 3 times 1 is a positive value. 1 minus 2 is a negative value. A positive times a negative is a negative. Okay, and then the last one that I'm going to test is a number to the right. So I'll pick 3. You could pick 10. It doesn't matter. If I pick 3, 3 times 3 is a positive. 3 minus 2 is a positive. A positive times a positive is a positive. So I just created my number line test. This is going to tell me interval of increase, interval of decrease, and if I have any max or mins. Okay, so let's first write what our interval of increase is. Our interval of increase is when my first derivative is positive, greater than 0. Well, that's happening in two sections. So I'm going to say it's from negative infinity to 0. The infinities is always parentheses. And you also have from 2 to infinity. That's my interval of increase. My interval of decrease, well, there's only one of that. That's where the first derivative is negative, less than 0, and it's going to be from 0 to 2. So those would be my answers for interval of increase and interval of decrease. Okay, well now let's talk about max and mins. I see I have a plus and then a minus. So I see at 0, there's a max occurring. So I have a max at 0, comma, we're going to talk about how to find that y value. And then I have down and up, that tells me I have a minimum at 2. So I have a minimum when x is equal to 2. Now, I'm looking for a maximum and a minimum on the original function. Your first derivative is describing the behavior of your original function. So in order to find a point that exists on the original function, yes, I know the point's a max at 0, but how to find the y value, you go back to the original, and that's really important. Put that into your notes right now. To find the y coordinate, of any max or min, you plug the identified relative extrema, so that max or min, into, and I'm going to write it really big, original function. So you're not plugging into the first derivative. You plug into the first derivative for the sign test, but to find the y value, you plug into the original function. My original function was up here. So if I take 0 and plug it into this original function, 0 cubed minus 3 times 0 squared plus 4, well, that's just going to be 4. So I happen to have a max at 0, comma 4. And today, I'm lucky that I have a picture. Yes, that is my maximum. And it confirms it's 0, comma 4. And then here, when I plug in 2 into this, 2 cubed is 8 minus 2 squared is 4 times 3 is 12 plus 4. Well, that just gives me 12. So that's going, that just gives me 0. So that point here, there's my minimum, and yes, there's my minimum, okay? So it's at 0, 2. And that is what you are going to be responsible for, all right? It looks like a lot of work, but it really does go in an organized fashion. If you're asked for max, min, interval of increase or decrease, you take your first derivative, you set it equal to 0, right here, you factor it and solve, and then you perform the sign test on the first derivative. And from that sign test, you decide whether you have an interval of increase, interval of decrease, and when you have your max and your min. All right, let's try another one. Here, I look at this and I see my graph. I see I have a minimum, right? But you're not going to see that. We're just going to confirm our answer here. If I say interval of increase, decrease, max or min, you go ahead right to work, first derivative. Now you have to decide what do you need to use here. This is chain rule. Now there was quite a few mistakes on the quiz. People were doing chain rule when you had a variable out here. You can't, but because you have no variable out here, you can do chain rule. That's the derivative of the outside times the derivative of the inside. Well, the derivative of the inside is just 2. So my first derivative is equal to 8, 2x plus 6 cubed. And that's all you have to do. What do you do with your first derivative? I set it equal to 0 or ask myself, will this ever be undefined? Well, this will never be undefined. It's only going to be undefined if I have a rational function, and I don't. So I'm just going to set the first derivative equal to 0 to find my critical values. So I'm taking 8 times 2x plus 6 raised to the third power, setting it equal to 0, dividing by 8. It's already factored. I'm just trying to get x by itself. You're going to take the cube root, 2x plus 6 is equal to 0, minus that 6 over, 2x equals negative 6, divide by 2, x equals negative 3. I just have one critical value. That's okay. Sometimes you don't have any critical values. If I ended up with an I here, there's no critical values. There's no max or mins. That's it. But in this case, I do. I have, wow, that's a wacky number line that I just drew here. Caught the crevice of my table. I'm going to put negative 3 there. I'm going to put the first derivative symbol here to show this is my first derivative number line. And I'm going to test. Where do I test into? You have to test into the first derivative. The first derivative is right here. So I do myself a little bit of a favor. I redraw the first derivative, rewrite it, I should say. And I'm going to test into this. I'm going to pick the value negative 4, and I'm going to pick 0. And I'm going to test what I get. So if I pick negative 4 times 2 is negative 8, plus 6 is a negative 2. A negative 2 cubed is a negative 8, but it's negative, and this is positive. A positive times a negative is a negative. So in this section, your first derivative is negative. All right, when I plug in 0 into this first derivative, that 8 stays positive. And when I do 0 here, 2 times 0 is 0, plus 6 is positive, 6 cubed is a positive. So this is a positive. So I see I have a minimum at this point, at this relative extrema that was identified. All right, so what do I get from this test? I got that the first derivative has I'm sorry, not the first derivative, good, g of x has an interval of decrease from negative infinity to negative 3. Now, make sure you know, look, I am glad I almost made that mistake to highlight that. Here, g of x, not g prime of x, has the interval of decrease. The original function is decreasing from negative infinity to negative 3. And then g of x has an interval of increase. Well, that's from negative 3 to positive infinity. All right, and then I decided, yes, I have a minimum at negative 3, comma, how do I find that y value? I have to go back to the original function, g of, and I want to plug in negative 3 to find that y value. 2 times negative 3 plus 6 raised to the 4th power, and I'm going to get 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. 0 to the 4th power is 0. So this minimum is occurring at negative 3 comma 0, which I did confirm by my picture that is a minimum. Okay, and I'm going to stop this one more time, and I'm sorry that it's 3 videos this time, but I wanted to do each one with you because it's pretty tricky.